Hey guys, the topic of our presentation is electromagnetism. I hope you guys enjoyed it till the very end. Now before we move on into study of our main topic, which is electromagnetism, first of all we should know the basics. So first, we're gonna have to know what a magnet is. Basically, a magnet is a material that produces a magnetic field. Now this field is invisible. Now you guys might be wondering what a magnetic field is. Well, basically, the space surrounding a magnet in which magnetic force is exerted is known as magnetic field. Now let's get to know how it's created. When current flows in a wire, a magnetic field is created around the wire. From this, it has been inferred that magnetic fields are produced by the motion of electrical charges. Now let's get to know what electromagnets are. The magnets which need electricity to flow are called electromagnets, and a magnetic field can change when the current in the wire changes, and that's one of the properties of electromagnets. Now let's get to know our main topic, which is electromagnetism. Electromagnetism has been defined as the science of charges and of the forces and fields associated with those charges. Electricity and magnetism are two of the most important aspects of this phenomena. Now these two forces, electricity and magnetism, these are really closely related. That's why scientists often consider them as a single force, known as electromagnetic force. As you guys might remember from grade 11, that the electromagnetic force is one of the four fundamental forces that exist in our nature. The other three being the strong force, the weak force, and the popular, the gravity. Now before I move on with physics behind electromagnetism, my mate Abiram is going to explain the applications of electromagnetism and how it's related to our modern world. So stay tuned.
Now that you know what electromagnetism is and how physics surrounds it, it should be easy for you to understand that electromagnetism isn't the only thing being surrounded. No matter what power devices we use, from something simple such as a clock to a smartphone, they all have some form of electromagnetic principle involved in their functioning. If there was no electromagnetism, we wouldn't have had the flexibility to turn on or off electricity for our desired needs. Right now, I'm going to be focusing on how electromagnetism is used in our society and its practical applications. Anyways, many of our electrical appliances at home, for instance, have electromagnetism as its base. Objects like an electric fan, for instance, has an electromagnetic principle of induction. This helps keep the fan blades rotating, therefore blowing air. Another great example would be an electric doorbell. When the button is pressed, it causes the coils to get energized, therefore with the help of electromagnetic forces, the bell sounds. Now, stepping away from the home appliances, many inventions have led to a very strong and secure way to use electromagnetism. If we were to take a long look at the modern safes, they are built with a magnetic locking device. These doors can have a numbered secret code or a magnetic card you swipe. The number keys are stored in a magnetic tape which is usually located on the back of the card. This interacts with the magnetic door, therefore opening it. Finally, another smart object would be a USB memory stick. This item is influenced by electromagnetism, similar to a bank safe lock. These memory sticks also have a magnetic tape which works with the electromagnetic principle. The data from the USB memory sticks are stored in electromagnetic formats in the forms of bits and bytes. Even the hardware in computers nowadays have these magnetic tapes. So as you can see here, what I'm trying to explain is that electromagnetism is being used all around our society. Electromagnetic forces are everywhere, from home appliances to computer hardware and memory storage. It is thanks to electromagnetism that we are even able to be more flexible with turning power on and off.
Guys, welcome back. Now that you guys have learned about the applications of the electromagnetism, we'll move on into a more in-depth study of the topic, and we'll also learn more about the physics behind it. So first of all, we'll learn that how does electricity create magnetism? Well, each electron is surrounded by a force called an electric field. When an electron is in movement, it creates a second field, known as a magnetic field. And when electrons are made to flow in a current through a conductor, such as a piece of metal or a wire, the conductor becomes a temporary magnet, known as an electromagnet. Now, electromagnetism has two meanings, and their meanings could depend on whether it's viewed as on a subatomic level or on an everyday scale. At a subatomic level, electromagnetism is defined as the force between electrically charged particles. It's considered one of the fundamental attractions of the matter. On a larger scale, however, electromagnetism is the creation of a magnetic field from the movement of electrical charges. It usually concerns the use of electric current to make electromagnets, which is called electrodynamics. When electrical charged particles such as electrons are put into motion, they create a magnetic field. When these particles are made to oscillate, they create electromagnetic radiation. This can include radio waves, visible light, or X-rays, and it all depends on the frequency of that oscillation. Now let's get to learn more about electrodynamics. Electrodynamics is basically creating a magnetic field from an electric current. When electricity passes through a wire, a magnetic field is created around the wire. Looping the wire increases the magnetic field. Adding an iron core greatly increases the effect and creates an electromagnet. You can also create electromagnet without the iron core. And as you know from grade 11, an electromagnet without the core is known as solenoid. When DC electricity is passed through a wire, a magnetic field rotates around the wire in a specific direction. The electrical charge passing through the wire seems to create a magnetic field. Now, to learn more about the direction of the magnetic field and the north pole or south pole of the magnet, we're gonna have to use a few rules. One of the most important methods of determining the determining the direction of the magnetic field is through the right hand rule. Now, to find the direction of the magnet field you can use the right hand rule. To determine it, if you take your right hand and wrap it around the wire with your thumb pointing in the direction of the electrical current, positive to negative, then your fingers are pointing in the direction of the magnetic field around the wire. Try it with your own hands. You can also see the direction of the magnetic field by placing a compass near the wire. You can try that too by doing an experiment. Thank you. You can cut the parts though, right? Cut the parts of the video. You can do it, right? You can cut it. I like that stuff.